I'm Anil Kumar sharing with you few questions from my subscriber who wants to understand how to use Pascal's triangle to find routes from one place to another. So I've taken up 4 examples here. This is the very first one. I'd like you to pause the video, copy the question, work it out, and then we'll discuss its solution. This is the most complicated of all, so I'm going to take it at the end. Let us first understand the process and then we'll make an attempt to solve this one. We'll begin with a simpler one, which is right here. It says determine the number of possible routes from A to B if you travel south or east. So let me mark the points A and B. So let us say this is A for us and this endpoint is B. Similarly here, we'll keep this as A and that last point as B, right? So let us see how we can travel from A to B, and while traveling, we'll try to count all possible routes. And the concept here is based on Pascal's triangle. Now, these are the blocks. We can only travel south or east. That means we could travel in this direction, which is east, or likewise, like south, right? So these are the 2 directions we can travel. Now let's begin by writing numbers. If I'm traveling east, and if I go along this path, there is only one way of going along this path. So I'm writing 1, 1, 1, 1, right? Similarly, if I move along the south side, there's only one way going south, so I can write this as 1, 1, and 1. Now, if I have to reach this point, I can reach from 2 places, correct? Since I can reach from these 2, we'll add those numbers, and so we get our number 2 here. So I hope this is very clear how we get this number. There are 2 ways of reaching this point. One is east and then south, and the other way is south and east. These 2 ways are represented by number 2. How about this position? Now there are 2 ways to reach here. So we have third. So it is 2 plus 1. You could reach from this side or from there. So add these 2 numbers to get the next number, which is 3 for us. At this place, 3 plus 1, 4, and continue the process, we get 5 there. Do you see that? So it's not that difficult. Now here, we'll add these 2 points. You can travel only south and east, so you can come from these 2 places. You cannot come from there. So there should be 3. And this position, 3 plus 3 is 6, 6 plus 4, 10, 10 plus 5 is 15. You can go straight, so those will also be 15. This is critical to understand. Is it okay? Now, let's come to this place. 1 plus 3 is 4, 4 plus 6 is 10, 10 plus 10 is 20, 20 plus 15 is 35. So 35. If you're going down, those points will be 35, right? This also 35. Now if I'm going east, I can reach here from 2 positions. So we'll add 15 and 35. 15, 5 plus 5, 10. Then we have 50 here. 50 plus 15 gives us 65 for the next location. Then we'll get to this. 50 plus 35 is 85, correct? 85 plus 65, 5 and 5 is 10, and 7 and 8 is 15, 150. Now, 35 and 85, you can use calculator. 5 and 5 is 10, 1, 9 and 3, 120. Now, 120 plus 150 gives us 270. So in all, we have 270 ways from A to B. Is that clear? Is that clear? Right? So take a moment, understand this process. Perfect. And then do this yourself. So now there are a few blank places here. Okay, so take care of that and see how it gets modified. So to begin with, if I'm moving east, 1, 1, 1, 1, 1. No problem. South, 1, 1, 1, 1, 1. These points intersection, 1 plus 1, 2, 2 plus 1, 3, 4, right? But here, you cannot go from this side. The only way is coming down from 1. So it is again 1. Do you see that? And 1 plus 1 gives you 2. Now back to second row. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 1, 11. And 11 plus 2 is 13. Now let's get back to this. 1 plus 3 is 4. 4 plus 6 is 10. 10 plus 10 is 20. 20 plus 11, 31. 31 plus 13, 44. Correct? Now, 1 plus 4 is 5. You cannot come from there, so still 5. You can come from 20 now. 20 plus 5 is 25. 31 plus 5, 6 and 56. 44 plus 56 is 100. Okay, this side. 5 plus 1 is 6, 6 plus 5 is 11, 11 plus 25, 36, 36 and that's it. 36 plus 100 is 136. So in this case we have 36 ways from A to B. Okay, so I hope the process is clear. So that was kind of a warm-up exercise. And now we have a word problem for you. It says, Anna is 3 blocks east and 5 blocks south of her friend's home. Right? So, Anna is 3 blocks east and 5 blocks south from her friend's home. How many different routes are possible if she walks only west or north? So in this case, she can walk either west or north, correct? So let's make the grid for us now. So in this particular case, what kind of grid will you have? So let's say, let's make axis first, okay? So Anna stays 3 blocks east. So let me draw 3 lines here. 1, 2, 3, right? So 3 blocks is 1, 2, 3 blocks east and 5 blocks south. That means friend's house is in the north, right? So we have 5 blocks. 1, 2, 3, 4 and 1, 5. So that is the friend's house. Perfect. So we can mark these 2 positions, A for Anna and F for friend. And now we'll find out how many paths are there. So if Anna goes straight up north, this is north, and then she can also go west, then be 1, 1, 1, 1 and 1. And as far as west is concerned from here, 1, 1 and 1. Now let's go. 1, 1 makes it 2. 2 plus 1 is 3. 3 plus 1 is 4. Now here, we could reach this point from these 2 directions. So 2 plus 1 is 3. 3 plus 3. So diagonally you have to add, correct? So it is 3 plus 3 is 6. 6 plus 4 is 10. Come back to the starting point. 1 plus 3 is 4. 4 plus 6, 10. 10 plus 10 is 20. 1 plus 4 is 5. 5 plus 10 is 15. 15 plus 20 is 35. 1 plus 5 is 6. 6 plus 15 is 21. And 21 plus 35 is 6 and 5. 56. Correct? So there are 56 ways. So that is how you have to do these questions, right? Sometimes it may be difficult to, they may get mixed up, but that's fine. Let's see the next question. It is a similar word problem. It says, Ryan lives 4 blocks north and 5 blocks west of school, right? So Is it possible for him to take a different route to school each day, walking only south and east? Assume there are 200 school days. So Ryan is walking only south or east. Is it okay? And now let's again make the similar kind of a grid as we did last time and then work it out. Okay. So Ryan lives 4 blocks north and 5 blocks west. So school is here, Ryan is there. So we'll make 5 blocks first for the school, right? So we'll make it towards east. 1, 2, 3, 4, and 1, 5. So these are 5 blocks west, 4 blocks north. So let's make 4 blocks this side. So we have 1, 2, 3, and 1, 4, right? So we get to the position of Ryan. So this is Ryan, and that is the school. So Ryan lives 4 blocks north and 5 blocks west. So from here, 1, 2, 3, 4 north, 1, 2, 3, 4, 5 west is perfect, correct? Let's write down the numbers. Ryan can move either east or south. So if Ryan moves south, then it is 1, 1, 1, and 1. Perfect. East, it will be 1, 1, 1, 1, and 1. Combined positions, 2, 2 plus 1, 3, 3 plus 1, 4, 4 plus 1, 5, 5 plus 1, 6, 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 15, and 6 is 21. Okay. 1 plus 3 is 4, 4 plus 6, 10, 20, 35. And when you add this, we get 56, 5, 15, 35, 70. And 70 and 56 is, let me write here, 6, 7, and 5, 12, 126. So we get 126 as our answer. Is it okay? So there are 126 routes. Is it okay? And says, Ryan lives 4 blocks north, but he has to go over 200 school days. So he has to repeat some. Is it okay? So he cannot go every day with a new route. So he cannot. So he has to repeat. Is it okay? So he cannot take a new route each day. Since the number of combinations is just 126, whereas there are 200 days to go for the school, right? So now let's get back to our original. So we are back to our first question, which was the primary objective. We have learned all the methods to do this particular question. A checker is placed on a checkboard as shown. The checker may move diagonally upward, although it cannot move into the square with X. So these are 2 squares with X. It cannot move into this location. The checker may jump over the X into diagonally opposite square. That means you can go from here to there or from here to this place. How many paths are there to the top of the board, which you have to find? Part A. Part B is, how many paths would there be if the checker could move both diagonally and straight upward, right? So those are the 2 parts, and accordingly I have 2 sets of drawings for you. You can actually pause the video, figure it out, and then look into my suggestions. So I'll keep a calculator handy because we may land up in big numbers here. So let's begin part A. Checker is there. We can only go diagonally. So best way is, let's go diagonally and mark 1 in all these positions. So it is, let me use a different ink, okay. Okay, let's use red is okay. So we'll mark 1. So 1, 1, 1, and 1, right? This side also 1 and 1. Okay, now let's look into it. Here we can reach from 2 places, so it becomes 2. and then here 2 plus 1 we have 3, and this place only 3 will move in. Okay, here 1 plus 2 is 3. Now this place we can go only from this side, so it is 3. Perfect. Now 3 can jump, come here, and this 3 can also come here, so we have 3 plus 3 is 6 in this location. Perfect. Let's get to this. 1 plus 3 is 4. Here only one way, only 3 can go there. Okay, this place 1 plus 4, which is 5. Now here 4 plus 3 7, 6 plus 3 9, and this diagonal only 6 can go. So that is what we have, and therefore the combination is we have to add 6 plus 9 plus 7 plus 5 to get the result. Is it okay? 7 plus 5 is 12, 12 plus 9 is 21, and 21 plus 6 is 27, correct? So that is our answer. So we'll just add 6 plus 9 plus 7 plus 5 to get our answer, which is 27. That is how it should be done. Perfect. So we actually made a mistake here. Let me correct this. This position is not correct. Okay, so it's good I saw this. So let us correct this one. So here you could actually also reach from this place. So it is 3 plus 3. So this should have been 6. So let me make 6 here. When this becomes 6, then some other numbers will also change. 6 plus 4, this becomes 10 for us. And here we'll have 6 and 6 as 12. So this becomes 12 for us. So those are the corrections. Since you can jump, right? So I forgot to add this 3 in this particular location. And therefore, these numbers are now 6 plus 12 plus, this is not 7 but 10. And the number will change. So let me correct it. So we have 6 plus 12 plus 10 plus 5, and the result is 33. So we get 33 as our answer and not 27. Okay, so I hope you understand what was the mistake. We could jump over this. So this 3 could go from here, and this could also go. Both will give us 6. Once we get 6 here, then 6 and 6 is 12, and 6 and 4 is 10. Perfect. So be careful when you do. You may or may not get exactly the same answer. If you don't get, recheck. Okay, now here let's get into the second one here. So this time we can actually go up as well as diagonally. So let's go from here. Going up means 1. Do you see that? Diagonal also 1, and left also 1. So we'll go a bit slow here. Now for this position we can go up and diagonal also. So we have 3 ways of getting to this position. Correct? Now 3 ways getting to this position. If here we get only 1 way, so 1 is perfectly fine. Now in this position we could come from 1 and from here, so that we get 1 plus 1 as 2. Now moving right is not a problem, only 1. Jumping, it is 1, and then going 1, that is safe. Now here we could go from 2 places now, up and diagonal, so we have 2. Now again, up or diagonal, so we have 2 plus 1, 3. Here we could come from 3 positions, so 3 plus 3 is 6. Now this position can be occupied by 2, 3 and 2, which is 7. Now here it could be combination of 3, 2 and 1, which is 6. And here it could be 2 and 1, which is 3. Okay, next level. Next level. So here we could go from these 3, so it is 16. Corner, 6 and 3, 9. Here, 7, 10, 16. This position 3, and 6, 9. Nothing is here. Now this position is only for 3. Okay, now coming to that position, 3 plus 1, 4. This position, 4 plus 1, 5. Here it is diagonal 3 and so 13. Here we have to add these 3, 19 plus 9, 28. This position we have 9, 16 and 6 because you can jump and come, right? So 6 and 16 is 22 plus 9, 31. Now next position, 7 could jump and come. 16, 16, 32 plus 7, 39. Okay, 6 can jump and come. So we got 6 plus 16, 22 plus 9, 31. Corner, 16 and 9, 25. Okay, so we are close. 3 positions, 5, 13, 18. 3 positions again. So let's add. So 28 plus 4, 32, 45. Here, let's add with calculator. Okay, so 31, let me add 31 plus 28 plus 13. That gives us 72 here. Here, 39, 28, 31. 39 plus 28 plus 31. 98. Next position, 31, 31, 39. 31 plus 31 plus 39. 101. So lots of numbers. Here, 39, 31 and 25. 39 plus 31 plus 25. 95. The last position here, 25 and 31. 56. Let's add them all. We get 56 plus 95 plus 101 plus 98 plus 72 plus 45 plus 18 plus 5. 490. Okay. So with my interpretation of the question, right, 490 is the answer. But I hope you understand the method. I might have done some calculation mistakes, that's okay, but it seems to be correct to me. So what I get here is 490. So when you say how many paths would there be if checker could move both diagonally and straight up, right? So we are assuming it can just step in any position, right? So upwards, diagonally or straight up, correct? And based on that, we came to 490. Anyway, I hope you found this interesting and was a good experience for you to learn the Pascal's triangle way of finding the routes. Feel free to make suggestions and your comments. If you like and subscribe, that'll be great. Thanks for watching and all the best.